All right, geometry class. Yesterday, the last couple of days, we talked about doing y equals mx plus b with slope and y-intercept. Today, I want to talk about point slope form. Okay, and this is how we're going to write the equation of a line if we're given a point and a slope. Okay, so to write the equation of a line, we need the slope and a point on the line. Okay, and we'll put it into point slope form. Point slope form. And the equation for point slope form, I'm going to put it here. All right. It's y minus y1 is equal to m x minus x1, with m is the slope. Okay. And in addition to that, I should probably put this on the notes. x1, y1 is the point. Okay. So what's going to happen is we have point slope here, y minus y1 equals m times x minus x1. What we're going to do is we're going to plug in a number for m, which is our slope, x1 and y1, which is our point. We don't need to worry about converting fractions to decimals here. I want to do the first one together, and then I'm going to give you guys time to do the last three. So I want to do the first one right here on the video. So using the points above, write equations of the following lines, leave some room. We'll write some stuff afterwards, but I'm not worried about that right now. So line AE. So AE. So A is at 3, 4. There's point A. Point E is at 6, negative 6. Okay. So here's our line AE. There and there. Okay. So 3, 4, and then 6, negative 6. Okay, remember our slope is our rise over run. So our slope, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It rises by 10 and runs 1, 2, 3. It goes down from left to right. So the rise over run is 10 over 3, but since it goes down, we're going to make it negative. Okay. So our slope is negative 10 over 3, just doing the rise over run between those 2 points, A and E. Okay. For our x1, y1, we can use A or E in the point slope form. Either one doesn't matter. Your choice. It'll be the same. It'll be the same thing. Okay. So again, point slope form, y minus y1 is equal to m times x minus x1. And for this one, I'm just going to use A as our point. Okay, we could use E, but I'm going to use A. So what we have here, ladies and gentlemen, is we have a slope of negative 10 over 3. So we'll put negative 10 over 3 in for our slope. Okay, point A is at 3, 4, so 3 is going to go in for our x1. And 4 is going to go in for our y1. And that's the equation of that line, right there. That's the equation of line AE. Y minus 4 equals negative 10 over 3, parentheses, x minus 3. All right, so take a few minutes and try the next 4 problems right here. Pause the video right now. Pause the video right now. Try the next 4 problems out, and then resume the video after you're done with those 4 problems. All right, coming to the third page here, if we, just a reminder, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. We talked about this yesterday. Okay. So say they give us a problem like this. Write the equation of a line parallel to DG that goes through point I. We have our point slope form. Okay. We have our point slope form. And so we have this. Okay, y minus y1 equals m times x minus x1. Parallel to DG. Parallel to DG means we're going to use the slope of DG. Okay, so we got to find the slope of DG. If it goes through point I is 2, 6. So 2 is going to go for x1 and 6 is going to go for y1. Okay, so we go back to our point slope form. Y minus y1 is equal to m times x minus x1. Point I, which is 2, 6, is going to be our x1, y1, so we can take care of that, x1 and y1. So we have 2 and 6. So now the real work here is we have to find the slope of DG. Again, we could graph DG up here. So point D is at negative 4, 5. Point G is at 7, 0. All right, so if we're finding the slope of this line, we go down by 5, and we go over by 11. Okay, so, and it's a downward line right there. It's a decreasing line, so the slope is negative 5 over 11ths. Okay, so the slope of DG, which is going to be negative 5 over 11. So that'll go in for our M. And there's the equation of the line. You don't have to do anything after that. Okay, so parallel to DG that goes through point I. So parallel to DG means the slope of DG. If it goes through point I, then we're going to use I, which is 2, 6, for our x1 and y1. All right, so you could do these following equations right here. So we have a parallel and a parallel. Right? Then when we have perpendicular, perpendicular, remember perpendicular, we just got to do the opposite reciprocal slope. Okay? Got to do the opposite reciprocal slope rather than the same slope. Okay? Try those problems out, and we will get to this later today and work on them together. Thank you and take care.